Hello, um, Dr. Mosley. This is our recording going over the machine learning tutorial. We watched the videos and we performed the code and we took some notes on it within the Google Collab. I'm Tim, and my partner's name is Gabe Womack. I'm Tim Alec.
Hi, I'm
Yeah,
over here.
yeah, that's Gabe. Um, we're recording on Microsoft Stream right now, so I don't know if you can see our faces, but we're just gonna talk through our code. Um, so at the beginning, it's pretty simple. We mount the Google Drive, so basically importing the drive using the Google Collab library. We copied the data set that we're going to be working on, which was confusion matrix, pretty print, and then the iris.csv. In here is just more imports. We make sure that pandas is installed for sure because we want to convert the CSV into a data frame, which you can see right here. So we have the count, the mean, standard deviation, the min, and then we have these different percentage values over here, along with the maximum, along with the sepal length, sepal width, petal length, and petal width. And then down here is when we start to define like more data processing variables. So we want to make sure that the strings for all of the varieties of the flowers transform into an int because that's the type of data type that our models are going to be consuming. And then as you can see here, we're basically just cleaning up the data a little bit, making it look a little bit nicer, still keeping it as a data frame with 10 rows. And as you can see, we keep all the data where the label is greater or equal to zero. Um, and in our case, that's all of them. Um, and then down here is when we start to get the features that we want to um, basically work with our models and the whole process in general. So this is us defining the features, and features are important for machine learning because you have to define them for the model. So we select the features, the length, the width for both the sepal and the petal for the flowers. And then we make a copy of the selected features using the data frame libraries. Um, and then down here, we return the selected features, the desired synthetic features. And then our define, here we define our get targets data frame. So this basically just takes in the data frame and then it returns a new data frame that only contains the selected targets that we're going to use for the model. So that's what we go through in this function. And then we define some parameters up here, and you could change them to just mess with the model basically. And then down here is defining more basically variables for pre-training, and then we have the number of the total examples, which is the length of the data frame. The number of training examples equals math.ceiling of the total examples of all the total examples in the training data, and then the validation examples equals the total examples minus the training examples. And then down here, so we're just basically redefining the features and the target features, and then we choose what percentage of the training data we want to work with. And then down here, we shuffle them. So this is basically randomizing the data in the data frame. And then down here, just reinitializing the feature validation and the target validation data frames. And then down here, are the validated features within a data frame. So this is like after all the data processing with the feature targets and the labels all properly defined. And then yeah, Gabe, you want to take over?
Yeah,
Let me
I got
know.
it from
Just let me
here.
know when to scroll.
Okay, I mean, you should be kind of able to tell. I'll just
Yeah,
go
yeah,
through it.
yeah.
But yeah, pretty much what we're doing here is we're creating a scalar. Well, the reason why we're creating a scalar is to make it so that our data frame can actually understand the data that we're feeding in and the data that's important. And then, yeah, I added some things down here in this section because I wasn't able to get some things to work. Like, so I had I think I have the scalars displaying slightly differently than was in the code with my print statements and the way I'm displaying it, but I'll show that off in a second here. All right, scroll Tim. So yeah, you can see in here. Here's the sepal length, sepal length, petal width, and the sepal area. And so those for the training features and the validation features. So basically, these are the two data sets that we're training and validating on. And then so you can see the model names. Right now we're trying to initialize our logical regression support vector classifier model, and then we're going to need our list for models later, our list model predictions for later, and our list model elements for later. And then scroll up to scroll. Yeah, there it is. So yeah, so right here, we're basically going to be training and fitting our our logistic regression model and our support vector classification model here. So pretty much we're going to declare our logistic model with the linear model dot logistic regression, set our solver .lbfgs with a max iterations of 1,000, and we're going to have it fit with our training data, and then we're going to make sure that it's correctly in a NumPy readable format by calling to numpy.rabble. And then we're going to do the same thing for SVC. And scroll. And then so you can see here, we're basically going to be adding our model into the list model, and we're going to be adding our prediction into our list model prediction. So you can see here, our model right now is going to be our logistic regression model, and then it's fit. And then our prediction is basically going to be our model dot predict, and then it's going to predict our validation features as opposed to our training features. And then we're basically going to print our logistic regression. This is something else I added where I added the accuracy, just because I was curious about that. And so I added the accuracy, but then you could see it printing out the actual predictions versus the actual target number. And same thing with the SVC model. It's kind of done the same way. And so you can see it right there. You can see predictions versus the actual labels. And so up there, you can see us, what's it called, implementing our confusion matrix. So basically, we're going to be using a confusion matrix now instead of the other models. And so basically, we're going to be using a confusion matrix for each of our models. I still get a little confused on these. It's a little interesting. But basically, we're going to store the confusion matrix for each model. We're going to, for each model in our list of models, we're going to create a confusion matrix, and then we're going to append it to the list models OMs. And after we do that, I add this little thing here to display the confusion matrix, display the plot of the confusion matrix, and then we're going to print the accuracy score, show off the accuracy score, and then and then that's pretty much all that's working there. And so there's the confusion matrix. You can see 8814. Scroll down, Tim. So that's the logistic regression. This is the SVC. Scroll down a little bit more. And then down here, you could see the basic confusion matrix stuff. This is just basically what we did up there, but without the data modeling.
Yeah.
And that's it.
Thank you.